Effect of frequency of incident radiation on stopping potential. The light radiations of same intensity and different frequencies are incident on the emitter C. The variation of corresponding photocurrent I with collector plate potential V for different frequencies is plotted as shown in the graph. For a given intensity, stopping potential is dependent on frequency and is more negative for higher frequencies of incident radiation and independent of intensity. Also, for a given frequency, the saturation current depends on the intensity of light and independent of frequency. Similarly, a graph for variation of frequency of incident light with stopping potential for 3 different metals is shown. For a given photosensitive material of the emitter plate, the stopping potential and the maximum kinetic energy varies linearly with the frequency, but independent of intensity of incident radiation. The intercept on x-axis gives the minimum cutoff frequency, called threshold frequency, for which the stopping potential is 0, which is different for different metals or photosensitive materials. Laws of photoelectric effect. For a given photosensitive material, the maximum kinetic energy of the photoelectrons depends on the frequency of the incident light radiation and is independent of the intensity of light radiation. For a given photosensitive material, the saturation current increases with increase in intensity of incident light, and stopping potential does not depend on the intensity of light. For a given photosensitive material or metal, there exists a certain minimum cutoff frequency, called the threshold frequency, nu0, of the incident radiation, below which no photoelectric emission is possible, whatever higher intensity of the incident radiation may be. Its value depends on the type of the metal. The photoelectric emission from a photosensitive surface is an instantaneous process without any apparent time lag of the order of 10⁻⁹ seconds